Hi everyone. Yesterday I solved the task min cost to connect all points using other approach. Approach was Prim's minimum spanning tree. Open up. It was it was not the same. It works by connecting the verticals of the graph, not traversing all the edges and sorting them out by their weight. So I have some extra code, unnecessary redundant code. It doesn't matter as at the moment. Last problems was pretty hard for me to solve. So I decided to step back and try and solve some issues from this roadmap. At least easy ones. I will analyze which of these I will try to solve, which I won't, and what I forgot. And go through this roadmap again until at least graphs and 2D DP. Probably I will come back to the methods earlier, but I'm not sure because 1D DP was easy, but 2D DP looks not easy for me. Also, last 2 days my head was filled by pretty much information and I need some rest. So let's watch from the beginning. Arrays and hashing. Let's estimate. Let's take a look on the task, at least on easy ones. Contains duplicates. I think I didn't solve it. Probably valid anagram and to sum. Oh, why you are lagging? I solved to sum, so I'm going to I have solved it and I remember it. What was it? What was the solution? To sum difference value. It was it was the one where we use the fact that that this number gives us the index of the item which gives us the sum, the target sum with this number. Yes, so we have inverse map where we put the array values, but we inverse the indices with values. In the map we have value as a key, we set value as a key, and the index as a value. So when we make it this way, we get the index of the number which sum with current number gives us equals to target. So, and that's how we find two numbers which give us target sum. If I remember the condition right, give an array, an integer target. Yes, return the indices of two numbers. They would have exactly one solution. Okay. Valid anagram and contains duplicate. Let's take contains duplicate. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Which topics do we have here? Array, hash table, and sorting. Why do we need sorting if we can use hash table? I don't know. We can use either sorting or hash map, but we don't need to use both of them. So let's try to find out if we use hash map. We traverse through items in the array. We put the item to the map. If it and check if the value already is in the map. If yes, we immediately return true and stop the loop, stop our iterations. If not, we add this number to map, and that's it. And that's how we solve it with all, I think, all complexity will be O logarithm n, but space will be the same, O logarithm n. Yes, maybe not. Yes, it will be the same. Okay, let's try. Var map, new map, var equals 0 while I less than increase I. If map has if map has value, return true. Otherwise, map set nums I, let's say with 1, and return false if all the values is distinct. Let's run it. Accept it. Let's submit it. Yes, it's pretty easy. We could solve it by using less memory, but how? I can't realize. Could we use sorting here? Could I even don't use map? I don't know. As I remember, it was something about. I solved the problem. It was about. It was the question with bit manipulation. And what was there? It was about finding duplicates. Yes or not? There was ZOR, and we made ZOR of each item, and I can't remember if it was. I can find it. Single number. Each element appears twice except for one. And this is not this one, that one, not about duplicates. But what if I try to get XOR each item, and what I will get in this case? Well, there is duplicates, there is no duplicates, etc. Okay, let's remove the map. We have the I. Then we can make nums for each value. We don't have to do it, and we made I. What is the JS bit manipulation? ZOR, equal I your value. Then I can console local value, and Returned false. Why not? And let's watch what we will get. Aha, not the value, but I. We got the one if there is duplicates. We get the last item each time. Okay, let's try to what can let's try each operator. Why not? Ampersand and operator. If we have 0 with 0 with each of it, there is no any correlation. Three, seven, seven. No correlations. What we have, XOR and not. Unexpected token. Inverts all the bits. It's probably it's unary. No. Yes. No. I don't know. Let's try combinations. 1, 4, 2. We just get last item. Not value. 1, 4, 2. No. The bit manipulations can't help me. So what can I do? What can I do more? I can sort it. I can sort array in place without using additional space. And if I sort it, then I can find I can find duplicate for second. Just going and checking adjacent items which could be repetitive, which are or is any of adjacent elements the same or not? If any of them the same, then it means we have the duplicates. What else? Don't know. let's sort them. X, y, x minus y. Length if nums I equals with nums I plus 1, return true. I increase I and return false. If we have, if there is, I don't need I here. If nums length less than 2, then return false. And that's it. Can we beat memory? Yes, but we lost runtime. Let's check solutions. Blah blah blah. Is it okay to just check everything? O(n) squared. Sorting. Sort it out. O(n) login where n is length. Hash set. Okay, I see. Unordered map, seen. Okay. Do we have sorting solutions? JavaScript one-line answer. Wow. How much is time complexity and space complexity? Interesting. Can it beat anything? Because it is an interesting approach. Well, it is pretty fast. I like it because it uses built-in structure, built-in JavaScript structure, and it's even not less than 10% of users with memory, so it uses not much memory. Solutions. using hash set, the same hash set usage on and on, nothing new. Is there for probably bit manipulation? Whoa, show me. Byte array as marker. I need an explanation because I don't get it. The value of each element in the table is to determine whether the index value has appeared before. This solution with bit manipulation is similar to that. Instead of using 0 or 1 in each element to show whether the number exists, it uses 8 bits of each element to indicate the existence of 8 numbers. For a number A, assume K1 is 8 divided by 8. K2 is a remainder of dividing by 8 plus 1. It uses K1 as the index for the lookup table to get an element. And then K2, K second element of the element is checked to find out whether A appeared before. If the bit is 1, return true, or if the bit is 0, set the bit to 1. Add A to the lookup table. For example, now we get a number 800. Then we get 100th byte of the table. The first bit is 1. So we know 800 appeared before. Moreover, other numbers means, I hope my it was not, sorry. I'm not understand it. This approach is failing. I can't understand this solution. Who can help me? Thanks. Changing 8 to 3 and 8 to 7 will make faster. This is super helpful, thank you. Could you tell me what the size of bigger? No, I don't understand Python. Hash map, sorting set, bit manipulation. Instead of storing elements in an array, we are using an integer for our storage. This approach involves setting the ith bit of an integer to 1, which means only the digit in that place will be 1 and the rest will be 0. I don't get it. I still don't get it. And then setting the ith bit can be done by computing shift by 1 for instance 1 1 equals 2, 3 1 is 8, which corresponds to checked for duplicates. We keep two integers, pchecker for storing positive integers and nchecker for storing negative. Each time we encounter an element, we add it to the appropriate checker by setting the corresponding bit to 1 using the OR operator. Before adding an element to the checker, we need to check whether it is already present. To do this, we use the AND operator to check if the current element bit is already set in the checker. If it is, then the element is a duplicate and we return true. Space complexity 01. Pchecker and checker. Let's take my second approach. I'm going to try this Python approach. Return false is the same, pchecker and nchecker, and rewrite it in JavaScript. We need a counter. If I more than 0, not I, but the number itself, yes, nums more than or equal 0, then do this, else do this. What is this? If pchecker and something with this more than 0, then return true. Pchecker, something like that. And here nums I, and here also nums I, not the I. Nums I, nums I, if checker p checker nums I, and here nums I2. Nums I. Probably it should work because operators looks pretty the same. It returns true. Even if we don't have repetitions. Aha. I didn't increase the I. Whoa. Runtime error. Line 21. Not ABS, but math ABS. Can I use this test case to check it locally? To check it without submission? Yes, it's work now. Oh my god, why it's wrong? I returned the true instead of false. Is it because of this array pretty big, or I need to use integers, or not integer, big int. Probably I need to use big int. Yeah. Base big int and types primitive number big int. Yes. Numeric values which are too large to be represented by the number is big int created by. Okay, let's try to use big int and let's try to run it. Run. Uh, 16th line. Let's try to run again. You cannot mix big int and other types. How can I convert to big int? Or by calling big int without and giving. Okay. Is it with big I? Yes. Wow, it works. Let's watch how it works. It loses. Okay, it's not a big deal. I guess it's because we make conversions. Okay, that's it for today. Thanks everyone who watched, who be here, and see you tomorrow. Bye everyone. Ciao.